Hi everyone, my name is Grace Huang and I'm a geomechanics product manager at Rocscience. Today I would like to talk about RocTunnel3, which is our latest software solution for underground block stability analysis. The topic is geometry repair for underground models. Your raw underground geometry may contain many defects. Now, the temptation is to repair all to fix all the geometry defects at once. However, depending on the number and complexity of defects, this process can be quite lengthy. So I would like to show you some quick alternatives for addressing some common geometry issues you might find in underground excavation models. The first issue is overlapping volumes. So you can see here that I have many entities as shown in my visibility tree. This stope, second one, third. This is an overlapping volume. This one, that's a drift. Another overlapping volume and drift. So you can have overlapping volumes in your model because your geometry may not always be clean. In this case, you have two alternatives, which is to merge the overlapping portions or to simply discard them. I'm going to use discard. Now, to safely do so, select the volumes. And I'm going to make sure the role is construction. And then geometry, discard selected construction geometry. And this is a good way to take care of overlapping volumes if they have similar geometries. Issue 2 is that you might have some parts of the model where the geometry is absolutely terrible, like I have one here. So you can see your geometry or the mesh by going to View and Show All Edges. And you can see my stope here has very thin degenerate elements, and it also has internally bad elements. In this case, the first thing you want to try is retriangulate. So I select the geometry, surface triangulation tools, and retriangulate. And let me check my stope again. So here is a very good example where due to the number and complexity of defects, retriangulate may not be able to resolve all the degenerate triangles. In this case, it may be easier to create a convex hull around the existing volume. So I have the stope selected again, go to Geometry, Surface Triangulation Tools, and then Convex Hull. And you can see here, basically, a convex hull wraps around the external surface of the existing volume and represents a very easy way to just generate a new volume based on the existing geometry. So I'm going to use the new convex hull and delete my original bad volume. So select it, change its role to construction. Then I'm going to discard the selected construction geometry. And make sure that my new convex hull has the role of geology. Issue 3 has to do with overall pore triangulation. It's good practice to make sure that all volumes can be reduced in the number of poor quality triangles. So I'm going to select all the pieces in the model and retriangulate. So geometry, surface triangulation tools, retriangulate. Issue number 4 is non-manifolds. A non-manifold is a T-junction, and you'll often find them where different volume pieces are intersecting. So in my model, you can see that I have separate volumes representing the stopes and drifts. To identify the non-manifolds, I'm first going to merge all the pieces using a low tolerance. So this should help to collapse some of the intersecting mesh triangles or the T-junction mesh triangles that are in very close proximity to one another. And let's check the status of the defects. Okay, and you can see what's interesting here, that we still have over 4,000 non-manifolds in the model. And coincidentally, these manifolds appear at where the different volume pieces are meeting, such as here and here where the stopes are meeting the drifts. So this tells me that the previous merge did not resolve some of the manifold issues. What we can do is to actually increase the tolerance of the merge. So I'm selecting my piece, go to Geometry, Surface Triangulation Tools, Merge. And this time I'm going to use a custom merge with an intersection tolerance of 0.5 meters. And let's check for the defects again. So now you can see that the number of non-manifolds have decreased 3 times. And what I would do from this step is to actually ungroup the non-manifold, so to ungroup the geometry at these T-junctions and to delete any unnecessary pieces, or the alternative is to select the pieces you want to keep from the ungrouping and just create a new surface with fewer defects. So let's first ungroup non-manifolds. And you can see there's so many volumes appearing in the visibility tree as a result of the ungrouping. And I'm going to do entity selection and just pick the pieces I want to keep. And after selecting all the important pieces, I'm going to create a new surface or enclosed surface for volume that has fewer defects. So surface triangulation tools, create from selected faces. Now I'm going to discard all the old pieces by setting their role to construction, geometry, discard selected construction geometry. And then set the new surface to geology. Lastly, after ungrouping non-manifolds and creating a surface from the important pieces, we want to do a final repair on this main geometry. So I've selected the surface, geometry, repair tools, repair. And you can see that the overall defect count has been drastically reduced compared to before. So at this point, let's just try repair all and then respond accordingly. After repair all, there could be a few defects left, and don't worry, these happen because previously there could have been a cluster of numerous defects or a cluster of defects from different types. So what I would do now is to zoom in on these individual defects, check what's going on, and then resolve accordingly. So for instance, here we have holes. So I'm going to repair selected, fix the holes first, select the cluster of holes, try repair. So this last piece here looks to be this joint from the main geometry. So to respond to this, I would try surface triangulation tools, ungroup this joint. And you can see that after ungrouping, this piece is now on its own, and we'll just work with the other piece, make sure that it is defect-free. Okay, and so for our final geometry, we have 0 defects left. I hope this video was helpful to you regarding the geometry repair process, and I hope it has shown you some of built-in geometry capabilities for RocTunnel3. Please feel free to request a free trial of this software and let us know below in the comments if you have any feedback or questions. Thank you.